So a lot of stuff that you've been working on also deals with graph transformations and what happens to the graph when you add numbers or subtract numbers or you change numbers or blah blah blah. Okay? And if I'm being 100% honest, this is not stuff I just like automatically remember like, oh yeah, that totally happens. But I can reason my way through these problems, which is something I'm going to show you how to do as well. Now, on your CSCOPE test, you have calculators. Now, during the class period, I know you kind of don't. So if you need more of like a notes thing to memorize, we can do that later. This is a way to reason through these problems when you have a multiple choice question or when you're kind of working other stuff out. Okay? So we're just going to, I have a bunch of questions and we're just going to go through them real quick and I'm going to show you how to do them. Okay? So number one, how does the graph f of x of, the radical of x differ from that one? Okay? All of these things you do, you can just compare them in the calculator. So you go to y equals here. And you do, oh god, it's just small, square root of x, okay? And then on the next one, you do square root of x minus 5. It's going to take a lot longer for me on this little thing. Okay, so there are my two graphs, okay? So I'm going to compare them. I go to graph, and so there's the first one, going super slow, and then there's the next one, okay? So all it did is it moved the graph to the right, shockingly enough, 5. Okay? So, we know that the number, so if I don't know if you're taking notes, but if you're just watching, the number under the radical moves it horizontally. Excuse me. And you're going to see that again with the next one. So, how does f of x of the square root of x differ from the square root of x plus 4? So we go back here, and then I'm going to go down here, and then instead of minus 5, I'm going to put plus 4. And then graph it. So there's my parent function, very slowly, and then there's my other guy. Okay? So yet again, it's moving it horizontally. Now, you got to remember that when you're subtracting, it's going right, it'll move right, and if it's adding, it's going left, which is kind of counterintuitive because, like, you would think, I don't know, when you think subtracting, like it's going towards lower, and then the adding would go towards higher, but you just have to memorize that. So that's something you might want to write down, or you need to memorize. And that's true also of quadratic functions and other types of functions as well, of rational functions too. So, if you subtract, you move right. If you add, you move left. That's just something you're going to have to memorize or put in the calculator. Like, if it's test taking time, you're like, crap, I forgot. If I subtract, which way do I move? You just kind of put it in there. Okay? So let's look at this next one. How does f of x of the square root of x differ from the square root of x plus 6? So the difference between the second one and the third one, oh my god, I'm dying. Excuse me, that's really gross. Okay, is the number is outside, or is not underneath the square root sign, okay? So we go to y equals. We still have square root of x. But for this one, we're going to do the square root of x, and I'm going to scoot over, and then I do plus 6. Okay? So how's that happen? So we go to graph. So yet again, there's the parent function very slowly. And if I do plus 6, it doesn't move it left to right, it moves it vertically, which is true. If you ever have a number on the end, a constant on the end, it's always going to move it vertically. So I'm just going to go ahead of here. I'm going to go as constant on the end, moves the graph vertically. So, and that's always true, whether it's a linear equation, a quadratic equation. If you have a constant by itself, it's going to move the graph vertically. Adding would go up, subtracting would go down. So you should know that, but just in case. What the crap? Okay, adding moves it up, subtracting moves it down. Okay? So, kind of basic stuff. And yet again, I haven't had to actually remember any of this stuff. I've just plugged it in to figure it out. So let's do one that's kind of big. The square root of x differ from square root of x plus 5, and then separately minus 4. So we each put that in there. So the square root of x plus 5, and then we move over, and then I put minus 4. So without even graphing, but let's say I didn't have a calculator. So before I even graph this, we should already be able to reason that the constant on the end will move it down 4. So it should move down 4. And then we already talked about that under the middle will either move it left or right. And when you're adding, if you add, it moves left. So it should be left 5, down 4. But let's see if that's what happened. So yet again, there's our parent function. So did it move left 5, down 4? And it sure did. That's left 5, and that is down 4. It's hard to see, but there you go. Okay? So you can either just remember the rules, but, you know, I don't even do that sometimes. Or you can just graph it and see visually what happens. We're very visual learners sometimes. Okay? So there you go. But what you're going to say is, well, what if they don't give me what if they didn't give me anything? What if they just gave me letters? Which you'll see from time to time, especially on, like, when you get to, like, AP tests or, you know, those kind of things, dual credit. What I want you to do is kind of just experiment. So, for example, how does f of x, the square root of the, not the square root, yeah, the square root of x differ from square root of x minus a? So basically, how does a change it? Well, we already talked about how subtraction moves it right, but let's just say you didn't know that. So you have square root of x there, and let's say you didn't remember that subtraction moves it right, and you have no idea what's going on. All you do is plug in numbers to see what happens. So x, so I put square root of x, and instead of minus a, just put like minus 3. Just pick a number and see what happens. And you would go to graph, and you would see that it moves it horizontally, which we already saw, but yet again, if you forgot, you could just pick a number and plug it in and see what's going on. So we would know that A moves the graph horizontally. Okay? So when you're faced with just letters and you're not quite sure what's going on, you plug numbers into them and you kind of see what's happening. And we'll get to that later. Okay? So that's all about square root functions. Okay? You know, radical functions, obviously. So that's all of that business. Now let's move to a quadratic function. And we're going to do the same thing, and then we'll kind of write notes as we go. So I'm going to go ahead and clear out all this business. So how does 3x squared minus 2x plus 5 differ from 3x squared minus 6x plus 5? So let's put 3x squared minus 2x plus 5. And then it differs from 3x squared minus 6x plus 5. Okay, so we graph. So here's the original. Okay, and then here's the new guy. If it ever graphs. Oh my god. Okay. So what we can see here, did I cut that in right? That looks weird. Maybe I cut that in right. So what we can see here is they're the same width, but what happens is that it shifted down a little bit and to the right, correct? And you're going to see the reason for that in a little bit, but when you see that, I believe when you had a homework assignment about this, it was multiple choice. So, for example, they're both opening the same way. They're both the same width, but you can see it move down and to the right a little bit, okay? So you need to be able to notice those changes. So we can tell that the middle number moves it, even if we couldn't tell that before. And it's not a specific like left-right kind of change, but you can definitely see the movement. And that's what I want you to be doing with your calculator is graphing them to see it. I'm actually going to change this one because it's supposed to be the same number. Minus 2. Okay. So how does f of... and that's supposed to be a 3. Look at me. I'm a mess. I don't even know what's going on over here. 3. Okay. So how does it change the back number? Okay. So the back number, let me go over here. So we're going to keep that the same. We're just going to change the 5 to a 1. This is super slow. Okay. And then here, we're going to do 3x squared minus 2x minus 4. That is not 2x at all. Now, I already said that the constant on the back will always move up or down, but this is going to show you. So, here's your original. And then here is your second one. Okay, so it did cross at 1, which is what that 1 comes from, and this is at -4. So it went down 5 because it was at 1 and it's down 4. So yet again, remember how I said the constant on the end moves it vertically. Okay? Now let's say that was a multiple choice question, and let's say you forgot that happened. You would graph them and see which one would move it down however many it was supposed to. Or you would graph the 2 and figure out how much it moved. Alright? So the number on the end just moves it up or down. Okay? Now, a lot of people in Algebra 2 will see, well, let's actually type that out. Constant on the end moves it vertically. Okay? Now, a lot of Algebra 2 kids, you'll get the vertex forms equation, and you have to figure out how H and K move it. When I had Algebra 2 kids ask me about this, I would say if you don't remember the rules, which we've talked about, the number on the end moves it up or down, the other guy moves it left or right. If you don't remember the rules, just plug in numbers. Okay, any numbers you want, and then we kind of figured out. So this first one is saying, how does it differ when you change H? So I'm going to pick numbers for A, H, and K. But I'm going to write 2 equations, but then I'm going to change H. So for example, instead of A, I'll just pick 2. Doesn't matter, I'll just pick it. Parenthesis, I'll do X minus 2. Okay? I just picked a random 2 for H. Squared, and then plus 7. Just picking random numbers here, okay? And then how does it differ when you change H? So I'm going to change this middle number. So I'm still going to keep the A the same, 2, X minus, but instead of 2, I'll do X minus 6, okay? Squared, plus 7. And then I'll graph it. So all I did was change H. So here's the original, whenever it decides to load. And then there's the new guy. In a second. There we go. Okay. The graphs look the exact same, but they moved horizontally. So I can tell, even though I had no idea before, just by plugging in numbers, I can say H moves the graph horizontally. And we already talked about, minus moves it right, adding moves it left. Okay? Same thing. But what about the next one where it says, how does it change when you change K? So let's go ahead and I'll keep the top one the same. I'll make this the same now. I'll keep H the same, so I'll make that a 2. But then I'll go ahead, not looking right there. There we go. But instead of plus 7, I'll go ahead and put plus 1. So I'm going to change K and see what happens. And go to graph. So yet again, this is me doing it without knowing any rules. I'm just plugging in numbers and seeing what happens. I'm reasoning my way through these problems. So I can see I have one problem up there. And I know it looks skinnier, but that's because it just moved. And you can obviously tell it moved vertically. It moved down. So you can say that K moves the graph vertically. Okay? So reason your way through problems. So if they ask what happens when you change A, change that and see what happens. Okay? Last, we're going to talk about rationals. And the reason I'm going to do that is because you have asymptotes and it gets all kind of crazy. So I've seen some of your homework and stuff like that. So I'm going to kind of go over these things and then I'll show you the asymptote thing. Okay? So what happens to the rational parent function? So let's clear all this bad stuff out. What happens to the rational parent function, which is 1 over x? So let's go ahead and put that in there. So that's there. When you replace x with x minus 2. So I'm going to put 1 over x minus 2. But since it's a group of stuff, you got to put it in parentheses. If you don't put it in parentheses, it's going to treat it like a fraction. It's going to treat it differently. So make sure you group it. Okay? So we go to graph. So there's the parent function. And x minus 2 is the same thing, but it moved right 2. Okay? And we talked about how minus moves things right, correct? So it looks kind of the same width, but all it did was it moved the graph horizontally. Just like we talked about, the stuff with x kind of moves it horizontally. And yet again, minus goes right, adding goes left. So we'll see. So this next one, what happens to the rational parent function when you replace x with x plus 4? So same thing. We do that and we put x plus 4. That is not where I wanted it at all. Plus 4. There we go. We go to graph. There's the parent function. And a lovely little moved function. And yet again, it moved it horizontally, and this time it moved it to the left 4. Okay? So I didn't know any of this before. Well, I mean, I did, but like, let's just say you didn't know any of this beforehand. Just by graphing it and looking at it visually, we can tell what's going on. Now, let's just take a little brief moment on rational functions here, because you do have asymptotes. So let's talk about that. Okay? So here's your parent function. And you know what? I'm actually going to zoom in so we can kind of see what's going on here. So I'm going to make everything 5. Negative 5. 5. Negative 5. And 5. Okay? So same thing, I'm just kind of zooming in to see what's going on here. Okay. So there are two asymptotes here. You have a vertical asymptote and a horizontal asymptote. And on the parent function, they're both at 0. Okay? And here's why. So notice you can put the number with x is the vertical asymptote. Okay? The number to the side is the horizontal asymptote. Alright, so let me show you what I mean. I'm going to put a number with x here. So x minus 3. So I'm going to redo this. And I'm going to put 1 over, make sure you put in parentheses, x minus 3. Okay? And I graph it. So you're going to see that it's the same thing. So the horizontal asymptote is still 0 because there's nothing to the side. So it's still 0. But now, yet again, subtracting moves it to the right. I have a vertical asymptote at positive 3. Okay? So the bottom number here is the vertical asymptote. Okay? Now here, let's see when I add the plus 2 to it. So go y equals here. I'm going to go to the very side. I'm going to put plus 2. If it'll let me. There we go. Hang on. Okay. So we got a graph. Yet again, here's the parent function. Now it's raised up 2 because it's plus 2, but we still have that vertical asymptote at 3. So the vertical asymptote's at 3, and then it did go up 2. So now the horizontal asymptote is at positive 2. Okay? So if you're asked anything like, hang on. I don't want to do that either. Hang on. So if you ask a question like, write a rational function with a horizontal asymptote of y equals 4, also negative 3, and a vertical asymptote of x equals 2. Okay? So let's say you have to do that. Here's what you're going to do. So let's take the parent function. So we have this, right? We want a horizontal asymptote of minus 3. So we know that the horizontal asymptote is the number to the side. So on the side here, I'm going to put minus 3 because that's where it's going to be. Now, the vertical asymptote is harder because you have to remember that subtraction moves it right, addition moves it left. So if I want an asymptote of positive 2, if I'm at 0, I want to move it to the right 2. So when I do that, I want to put minus 2 right there. Okay? And this would be the correct answer. However, let's say you forgot and you put plus 2. Okay? Always check your work. So you would go to y equals here, clear this out, and you would type that in. So 1 plus x plus 2, close it, minus 3. So let's say that's what you got. I'm going to put in the calc. Whoa, why did I put plus there? Should have stopped me beforehand. 1 divided by, there we go. That's not what I wanted either. Okay, now we graph it. So let's say that's what you got. and then you graphed it, and you were like, whoa, my vertical asymptote is at -2, not +2. But it is the horizontal one is at -3. That's good. So then you would go in here and you would change it to -2. You would go here and double check it. So -2. That's not. This video should be titled Miss Melina Not Understanding How to Work a Calculator. There we go. And then you would redo it and you'd say, hey, that looks more like it. We got a horizontal asymptote where it should be. We got a vertical asymptote where it should be. And then we're done. Okay? So all of these things can be done in the calculator. Okay? A lot of your things can be done. Don't be afraid to use it unless you're not allowed to in class. And then we can talk about, that in the future. If you have questions about anything I'm going over, please let me know. I'm available. Just let me know.